An interface is like a class that doesn't contain any implementation. An interface contains a structure, signatures, but there's no code inside. A public interface is a list of method definitions. When you inherit from an interface, it's like signing a contract. You've agreed to implement all the methods that that interface contains, but in return, the interface will not change its public interface. That means that it's agreed not to change the actual method signatures. This serves to protect the applications that have already been built to use these interfaces. There are lots of benefits to using interfaces. Interfaces provide a list of common services or behaviors for classes that implement them. Interfaces also provide a way for C# to provide multiple inheritance. Remember that C# is a single inheritance language. You can only inherit from one base class. But by allowing a class to also implement interfaces, it has a chance to provide multiple inheritance. Interfaces are declared in a very similar way as classes are declared. Instead of the keyword class, you use the keyword interface. Let's take a look. Here's an example at the top of the screen of an interface. Now, naming conventions for interfaces determine that an interface starts with a capital I. So the name of this interface is actually going to be capital I shape, a very common naming convention, not required, but it is a naming convention. Notice the definition of I shape. Instead of saying class, I say interface, and then the name of the interface. Now this interface is actually going to have two method definitions in its interface definition. A draw method that returns void, no arguments, and a draw 3D method that returns void with no arguments. So it's fair to say that this is the public interface that iShape is offering. Now notice that there is no access modifiers here for any of the methods. You can't include access modifiers here. It is implied that these methods are public. So I wouldn't want to include the public modifier. If I do, I'll get a compile error. Now take a look above and you'll see 4 classes that are good candidates for implementing the iShape interface. Square, circle, rectangle, and triangle could definitely use these public interfaces. That is, these are common behaviors that you might find across all 4 of those classes. The difference is that all 4 of these classes, if they were to implement this interface, that means that they would have to implement all the method signatures that are inside the interface. Keep in mind that interfaces have no implementation. That's one of the main characteristics of an interface, is there's no code inside. It really just stores a public interface. When you implement iShape, what you've agreed to do is take all the methods inside of iShape and implement them, meaning that you're going to put code behind all of these methods. Now take a look at the structure here and you'll see that square, circle, rectangle, and triangle could all use a draw and a draw 3D method. That method probably is the way that those shapes are drawn. But every shape is drawn differently. A square, for example, is drawn really differently than a circle. So this interface provides a list of standard services or behaviors for all 4 of those classes. And when those classes actually implement the interface, they'll be writing code in both of those methods, but the code will be really different. So They have the same behaviors, but the implementation of those behaviors will be different. When you have a class that implements an interface, that means that the members of the interface have to be implemented by your derived class. Remember that the members' signatures must be identical to the signatures that are defined in the interface itself. That includes the access level of the method, the return type, the name of the method, and the parameter list. Let's take a look at an example. In this example, I have a public interface called iShape. iShape has one method. It's draw. Draw is a void return type with no arguments. Notice that public is implied here. All of the members of an interface are public. In the bottom code, I have a class called Circle, and Circle is implementing iShape. And that's the syntax right here. Circle, iShape. Now notice what Circle has done. Circle, as a class, has signed a contract, and the contract is that it's responsible for implementing all of the members of the iShape interface, and that's what it's done here. Notice I have public. It's the same access level as the definition in iShape. Void is the return type, the name of the method, and the argument list. Notice just by showing the braces, just by indicating those, I have in fact implemented the draw method. Now certainly the code inside here that I would want to write is code that draws a circle. But it's really enough just to put the braces in the method. That's what makes it implemented. Interfaces provide a standard set of behaviors for your classes. In fact, there are many interfaces in the .NET Framework class library. If you wanted to create standard classes that provide standard behaviors or services, you could implement predefined interfaces that are available through .NET. Interfaces allow a set of classes to have standard behaviors.